here, I'm going to talk about how to compute the value function. So a simple example is the goal search example. So suppose you have a goal here and you have the states S1, S2, S3, S4, S5. So if you reach the goal, for example, from this direction and from this direction, you'll get reward 100, otherwise you'll get reward 0. Otherwise, reward is 0. So if you're at G, you'll stay at G and get 0 all the time. So the first thing you need to define, in order to find the value function, you need to define a policy function. Policy function basically map any state to an action. So one example of policy function that's not optimal is S2 would go to S1, S1 will go to S3, S3 go to S4, S4 go to S5, and S5 go to G, and G go around. So an example of pi is equal to, say, the blue arrows. So if you actually want to write it down precisely, you say pi of S1 would be equal to the action of going down, pi of S2 would be the action of going to the left, and so on. So that would be a policy function example. So for each value function is associated with a policy function, and it's also evaluated on a state. So I'll solve one example, and I think it should be easy to solve the other ones. So the value function given this policy, the value at S1 means you just follow the policy. At time 0, you are going to move down because you are at state S1. You follow this action of going down. Going down gives you 0, so you get 0 reward in the first period or in the first iteration. And then you move to the right. So let me actually write down. So this 0 is from going down. And in the next period, you are going to get the value is going to get discounted by gamma. So for example, if gamma is 0.9, I'll just put 0.9 here, and it's multiplying by the next policy function. So pi of S3 is going to the right. So this is the reward from going right, which again is 0. And next period, again, from going to the right again, which is this one, you get 0.9 squared and 0. So basically, in time period t, you get gamma to the power t times the reward of that actual action you take in that period t. So that's the general formula. And then in the next period, from going up, you are going to get 100, and you get 0.9 to the power 3 times 100. And after that, you get 0.9 to the power 4 times just going around 0, 0.9 to the power 5 times 0, and so on. So all of them are 0. So the whole thing, the other things are 0 as well. So the only number is 0.9 to the 3 times 100. So I think it's around 72. So that would be the value function given this policy of state S1. So of course you can compute the value starting S2, which is in this period is 0, next period is gamma times 0, next period is gamma squared times 100, and then all the remaining periods are 0. So here you get 81, and so on. So you can compute the other states the same way.